So what we have here is a drawing on how to determine the center points on a PCD. Up the top here you can see that I've got definition for PCD, which is the pitch circle diameter. The pitch circle diameter is actually this red line here going around here, so that's the center that we will be wanting to put our points on. So that is what's known as a pitch circle diameter. So flanges over here, top left hand corner, any flange like this, you can see the one on the right has got 5 holes in it, the one on the left has 6 holes in it. Those holes are actually drilled on the PCD, and what we're going to use is a formula for a chord length over here on the right. Calculating a chord length for a PCD, so we'll work through that. Back over here on the left hand side at the bottom, I've built up a chart, PCD factors, so you can see the number of holes that you want to put in, 2 all the way through to 20. You could have more than 20, which means that you would actually go back over and use the top formula, chord length equals diameter times sine A over 2. So if we're over here on the left again, we're using 5 holes, the factor we're going to use is 36. If we were using 14 holes, the factor would be 12.857. So, top formula, as it says, chord length equals diameter times sine A over 2. The example I'm going to do is for 5 holes on a PCD of 250 millimeters. That 250 millimeters is actually the diameter. So the first thing we would do is we would divide the 360 circle by 5, and that's going to give us 72 degrees between all the holes. So in this top left hand drawing, it's 72 degrees between each of these holes. From the very center, that would be the arc angle, 72 degrees. So putting that into the formula, we have chord length equals diameter, in this case would be 250 times sine 72 divided by 2, because 72 was the angle. 5 times 72 equals 360. So first we would have to divide the 72 by 2, which gives us 36. So that's the 36 degrees. Over here on the left, the 5 equals 36. So that's how we get that figure on the left-hand PCD factor chart. So the equation now looks like the following. The chord length equals 250 millimeters times 36 degrees. Therefore, the chord length equals 146.946313 millimeters. Once again, in all of my drawings, the computer works to very, very accurate numbers. You don't have to be as accurate. 146.9, you're probably going to be very close using a set of dividers or a compass of working on a basis of 147 millimeters. You're not going to be able to get it much more accurate than that. So, my next statement is down here is, however, by using the factors in the chart to the left, we can change the formula immediately to that second step of chord length equals diameter times sine A, which was what we worked out here. So example, once again, 5 holes, PCD 250, therefore chord length equals 250 by sine 36. So chord length equals the 146.946313, and that's what we had up here. So if you have more than 20 holes, let's say you wanted to put 25 holes in it, you divide your 360 degrees by 25, work out what that is, divide it again by 2, and that's what the number you would put in for sine. So just as an example. So the dimension we're looking for is 146.946313. So how we would put that on the circle, you would use a set of dividers or a compass. I'm using arc on the computer. I need to set up a center. I'll start at the very bottom. My dimension I'm putting in is 946.313. You can see it being entered down on the bottom left hand corner on the command bar, and pushing enter for that, and I'm just putting a little arc through there. That's how you would do it with a compass. It's a bit slower for me on here using this method, but I need to demonstrate it for you. So just putting these lines in here, another one, center again, coming over here, 146.946313, pushing enter, drawing the next one. Didn't want to hit that, so we'll do it again. ARC, center for that, 146.946313. And so I've drawn 4 lines. The one right at the bottom here is actually my 5th one, but I'll just show you that it does go back to that point. So center onto that point, type in my dimension again, and drawing my arc through there. So we'll zoom in on that. You can see that it's actually hit dead on that point. So that's how we can determine that it is accurate on this drawing. So what I've done there, as you can see, let me just zoom in here and change to pan. These points here, 5 points dead on that circle there of 250 millimeters diameter, radius being half of that at 125. I've got 5 equally spaced points around there. So that's what a chord length is. A chord length is actually a straight line length across a circle. I'll just draw that. We'll go from this one here to this one here. So that's what a chord is, just a line like that that goes across a circle. And if I want to dimension that, just to show you, I forget what scale my dimension is on, so it's pretty big, but look at that. I'll just bring that back. Where have we got scale? Text height. And we'll go to 0.8 on that. So there you can see it. It's sitting there at 146.95. They've actually I can change the precision of that out a bit more. So there it is. There's the dimension that I was working with, 146.946313, and that's what we were putting around the circle. So we'll just get rid of that. So that's how you work out a PCD on a circle using this formula over here on the right hand chart of chord length equals diameter times sine A over 2. By using the factor chart over here on the left, you can dump it straight into this formula here of the diameter of 250 in this case times sine 36, and that's the quickest way to do it. If you copy the factor chart down, that will help you immensely. So there you go. Thank you.